to Tennessee at Home Learning Series for Math. Today's lesson is for all third grade out there, though all children are welcome to tune in. This is number 16 in a series. My name is Lisa Sharkley, and I'm a third grade teacher at Venus Stewart Elementary in Gallatin, Tennessee. I'm excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see the previous lesson, you can find it at the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson if you hadn't seen the others, but it might be better to watch those because I'll refer back to them. Today we're going to be learning about using strategies to multiply with 3 and 6. For you to fully participate, you'll need paper, pencil, and a hard surface to write on. Okay, let's begin. Lesson 16, Multiplication Facts and Strategies, Key Vocabulary. I have some words. Will you say them with me? Multiply, factor, product, equation. Those are some of the words we'll be using for Lesson 16. Today we will be learning about using strategies to multiply with 3 and 6. All right, let's get warmed up first. First, let's multiply by factors of 2 and 5 to solve some review problems. All right, I have a student, Elena. Let's see what Elena's doing. Elena scored 18 points in her last basketball game. All of her points were scored by making baskets worth 2 points each. How many baskets did Elena make? Now we're going to solve this equation by writing a multiplication equation to match it. Okay? So I know Elena, she scored 18 points playing basketball. All of her points were scored by making baskets worth 2 each. So let's start breaking this one apart. I know this is going to have an unknown factor. I know that because I don't know how many baskets she scored. So I'm going to put my blank because that's for the number of baskets she scored. I know it's times 2. Each basket was worth 2. And I even have my product, which is 18. So I have to decide how many baskets did Elena score. I can do that by skip counting by 2 to get to 18. Can you do it with me? How many 2s does it take to get to 18? Let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18. I skip counted by 2 9 times. 9 times 2 equals 18. Good job. We're off to a good start this morning. I think we have one more warm-up problem. Yes, let's do one more review problem together. All right, I have another student, Jayton. Hey, Jayton. Jayton and his dad own 7 banjos. They need to replace the strings on all of them. Each banjo has 5 strings. How many strings should they buy? Again, write a multiplication equation to solve the problem. So, as I'm looking at this one, my 7 banjos is my group of. I have 7 banjos. That's my group of number. That's going to be my first factor. Times, each banjo has 5 strings. That's going to be my second factor. How many's in each group? Now I need to find the product. I can say 7 times 5 equals, or I think I'm going to flip those factors and think 5 times 7. Because I can count by 5 7 times very easily. All right, will you count by 5s with me? Let's go. 5, 10, 15, 20, 25, 30, 35. My product is 35. So if 5 times 7 is 35, so is 7 times 5. All right, Good way to get warmed up this morning. Let's see. Help me solve this problem. Asia, hello Asia. Asia is making triangles with toothpicks. She uses 3 toothpicks for each triangle. She makes 4 triangles. How many toothpicks does Asia use? Let me read it one more time because I need to make sure I'm making sense of what this problem's asking me. Asia's making triangles with toothpicks. She uses 3 toothpicks for each triangle. She makes 4 triangles. How many toothpicks does Asia use? I think it would help me by drawing a picture on this one. Let's start off with a picture. Now she's making triangles. Show me with your fingers how many sides a triangle has. And you should be showing me 3. All right? Let me draw my triangles. So 1 triangle, 2 of them, 3 of them, 4 of them. I have my 4 triangles drawn. So this lets me know 4 triangles times 3 sides, how many sides? I can use my triangles and skip count by, yes, 3. I agree. Let's try it. 3, 6, 9, and 12. 4 times 3 equals 12. Let's keep going. Now, find the total number of toothpicks needed to make 6 triangles. Draw a picture to help. Let's do that same strategy, but I'm going to have you doing this one. Draw your triangles, write an equation and an answer, giving you 15 seconds. All right, let's look at it. I'm going to start off by drawing my triangles to match. 6 triangles, 1, 2, 3, 4, 5, 6. I have my 6 triangles. Now I know this problem is saying 6 triangles. We've already decided that a triangle has 3 sides. So my 6 would represent my group. The number of triangles times my 3 would represent the number of sides. 6 times 3, could I skip count by 3 and find the answer? I could. Let's try it. 3, 6, 9, 12, 15, and yes, 18. 6 times 3 equals 18. She would need 18 toothpicks to make it. All right, good job, guys. How can we use what we know about the number of toothpicks needed for 4 triangles to find the number of toothpicks needed for 8 triangles? Do some think time about that. How can we use what we know about the number of toothpicks needed for 4 triangles to find the number of toothpicks needed for 8 triangles? Well, as I think about that, I know that 8 is double the amount of 4. So, if I know that with 4 triangles, 4 times 3 equals 12, could I double that amount and it would tell me how many I would need for 8 triangles? 8 times 3 equals, So I could say 4 times 3 equals 12 plus another 12. I doubled it, and that would give me my product of 8 times 3, which would be 24. So yes, that's that doubling strategy that we'll talk more about today. All right, let's keep our engine going. Now let's consider some strategies we can use to multiply by the factor of 6. If you already know your 6's facts, that's wonderful. This is a great opportunity to practice and make mathematical connections. Let's see about Savannah. Hello, Savannah. Savannah is using toothpicks to make 6 octagons. How many toothpicks will she use? All right, first I need to make sense. Octagons. Again, show me with your fingers, how many sides does an octagon have? And I bet you're showing me 8. I hope you're showing me 8. There's 8. So, she's making toothpicks. She's making 6 of them. So 6 would represent the number of groups, times 8 would represent the sides of an octagon. Okay? Let's see. I worked this a different way. I want to model to you a different way to work this problem. Let's keep going. Here's a picture to illustrate my thinking. The shaded rows of the area model show 5 groups of 8. 1, 2, 3, 4, 5 rows. And in each row there's 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's kind of chunk that one. So 5 rows, 5 times 8 in each row equals, count the 5s. 5, 10, 15, 20, 25, 30, 35, 40. But then I have one more row at the bottom. The shaded row of the area model shows 5 groups of 8. The shaded row plus the one unshaded row shows 6 groups of 8. So I can't forget about this one at the very bottom. I'll draw my line. Again, how many rows do I have? 1. How many's in that row? Times 8 equals 8. So for me to find 6 times 8, I can put my 5 times 8, which equals 40. 40 plus my 1 times 8 that equals 8 together to get the product. 40 plus 8 equals, I'll pause for you, yes, 48. So we can use our 5 facts and addition to help us find our 6 facts. That's going to be another strategy that we practice this morning. What is the doubling strategy? The doubling strategy says if I know a multiplication fact where one of the factors is 3, then I can double the product to find the related multiplication fact where the factor is 6 instead of 3. That's what this doubling strategy that I keep mentioning means. Let's look at some examples. All right, there's Gabe. I'm going to say, hey, Gabe. Gabe and his family ate 3 loaves of bread a day. Each loaf has 6 pieces. How many slices of bread did Gabe's family eat? Well, I know that's a multiplication problem. I have my group of, there's 3 loaves times how many's in each group. Well, there's 6 pieces. I can count by 3 6 times to find my answer. 3, 6, 9, 12, 15, 18. 3 times 6 equals 18. Now let's see if we can use this problem to help us with this one. Gabe and his family's appetite increased. They began eating 6 loaves of bread a day, with each loaf having 6 slices. How many slices of bread did his family eat? So again, 6 is my first factor now. 6 is my group of. How many loaves? 6 loaves. How many slices is in each loaf? 6. So now 6 times 6. Well, I know that 6 is double 3. So, can I think 18 plus 18 would give me my answer to 6 times 6? I could. I'm using that doubling strategy. So, I could say 18 plus 18. If I add those two 18s together, 8 plus 8, 16. 6 carry my 1. 1, 2, 3. 6 times 6 equals 36. I used a fact that I knew. 3 times 6 equals 18. Doubled it to find 6 times 6. Good. Alright. Now let's consider, oops, I went the wrong. Here we go. That was Gabe. Let's use the doubling strategy to solve this problem. What is 3 times 5? Well, we know, tell me real quick. And I know you said 15. How would the doubling strategy help you find 6 times 5? So again, if 3 times 5 equals 15, and 6 is a double of 3, I could say 15 plus 15 equals 30. Doubling strategy. Let's try this one. What is 3 times 9? All right, I'm going to do my skip counting. 3, 6, 9, 12, 15, 18, 21, 24, 27. Let's see if I counted by 3 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 times 9 is 27. How would the doubling strategy help you find 6 times 9? I can do the same thing. I can say 3 times 9 equals 27, and 6 is a double of 3. So I can add my product twice to find what 6 times 9 is. 7 plus 7, 14, 4, carry my 1. 2 plus 2 is 4, plus 1 is 5. 54. This is just another strategy if you don't know your 6s very well, to use 3s that I hope you do know very well. I'm going to have you practicing some in a couple minutes. Okay? I'll do the first practice problem together. Use a 5 fact and addition to solve the problem of 6 times 4. Okay? So, I like to draw a line under this. It's asked me to use a 5 fact and addition to solve the problem. So I can think 6 times 4. Well, if I use a 5 fact, I'd make the 6, I'd break it apart to a 5 and a 1, because 5 plus 1 equals 6. I'm still multiplying times 4, times 4, times 4. 5 times 4 equals 20. 1 times 4 equals 4. So 6 times 4 is equal to 20 plus 4. 20 plus 4 equals 24. I use a 5 fact and addition to get that answer. Let's do the same thing here. Use a 5 fact and addition to solve the problem of 6 times 7. Again, I'm going to do my line. They've asked me to use a 5 fact. So what 5 fact could I use? I would say 5 times 7. And then I only have 1 left. 1 times 7. 5 times 7 equals, yes, 35. Plus 1 times 7 equals 7. When I add that up, that would come to, carry my 1, 42. So 6 times 7 is equal to 35 plus 7, which is equal to 42. We're on a roll now. Now try these on your own. Use a 5-fact and addition to solve 6 times 3. Do just like I had showed you. Draw that line underneath. Make it into the 5-fact. How many toothpicks would Ivy need to make 6 squares? Oh, think about how many sides a square has. Hint, hint. And the last one. Would Ivy use more toothpicks for 5 squares or for 6 triangles? Write equations and explain your thinking. So I'm asking you to work on 3 problems. I'm going to step back and give you 1 whole minute to work on these 3. Just like we had worked this, making this into a 5-fact and addition, 6 squares, and would Ivy use more toothpicks for 5 squares or for 6 triangles? Work on it, please. All right, I'm back. Your 1 minute's up. Let's look at the first one. Use a 5-fact and addition to solve 6 times 3. All right, I'm using my 5-fact. I'm making that 6 into a 5 and a 1. Okay, then I'm bringing down my times 3. Times 3 times 3. 5 times 3 equals, yes, 15. 1 times 3 equals 3. Let me write it going across. 6 times 3 is equal to 15 plus 3, which would add up to 18. 18 would be the product, using my 5-fact to solve. All right? If you had that one right, kiss your brain. Mwah. All right. How many toothpicks would Ivy need to make 6 squares? Now, show me with your fingers how many sides a square has. And you should be showing me 4. So, this is saying 6 times 4. All right. I could use a strategy. I could do, oh yes, let's do that. I like that idea. Let's make this into a 5-fact and addition. The 6 would turn into a 5 and a 1. 5 times 4. 1 times 4. 5 times 4 equals 20 plus 1 times 4 equals 4. 20 plus 4 equals 24. All right, if you got that one right, give yourself a round of applause. And our last one, would Ivy use more toothpicks for 5 squares or for 6 triangles? So let's think about this one. 5 squares. 5 is my group. 5 groups. How many sides does a square have? And you had said 4. 5 times 4 equals 20. Yes. Or for 6 triangles. 6 is my first factor. It tells me the group number. Times triangle. I'd have 3 sides. 6 times 3 equals 18. Alright, so which one? Would Ivy use more toothpicks for 5 squares or for 6 triangles? If you said for the 5 squares, you are so right. And I'm giving you a lasso cheer. Good job, guys. Great work today, students. Today we reviewed using strategies to multiply with the factors of 3 and 6. I hope you are recognizing that you can use known facts to help find unknown facts. I will show you the independent practice for you to work on. Thank you for inviting me into your home, and I will see you on our next lesson of Tennessee at Home Learning Series for Math. Bye-bye.